In today's video, we will take a fascinating journey into the past and explore the historical context of aircraft powered by nuclear energy. So, sit back, relax, and delve into the captivating history of nuclear-powered aviation. Let's get started. Aircraft propelled by nuclear energy. Let's step back and examine the historical context of aircraft propelled by nuclear energy. Those who have seen the GI video likely know that nuclear-powered aircraft is not a novel concept. It was not an innovative weapon system or technological advancement. During the Cold War, the United States and the Soviet Union developed such equipment. Development of nuclear-powered aircraft. The United States designed a nuclear-powered bomber based on the B-36 bomber as an example. They designed the NB-36H, a nuclear reactor-powered prototype aircraft. The Soviet Union, on the other hand, chose the TIP-U-95 strategic bomber as a platform for conversion, resulting in the creation of the TIP-U-119 Swallow, an experimental nuclear-powered bomber. Obstacles and limitations. However, the fate of these two aircraft demonstrates that nuclear-powered aircraft were impractical during that period. There were predominantly two major obstacles. Miniaturization of nuclear reactors presented an initial difficulty. Whether the American NB-36H or the Soviet Tu-119, the utilized nuclear reactors were enormous and heavy. The core device weighed 2 tons by itself. Additionally, extensive radiation protection apparatus was required for the operation of a nuclear reactor. These systems could therefore only be deployed on larger aircraft such as strategic bombers. Nuclear reactors and weight constraints. In addition, there was considerable concern regarding the safety implications of a nuclear-powered aircraft. If a nuclear-capable aircraft were to fall, the likelihood of a catastrophic double nuclear accident was high. Recent incidents involving nuclear submarines, such as the one on April 7, 1989, when the Soviet Navy's Type 685 Finn-class attack nuclear submarine Comso Incident caught fire in the Barents Sea, emphasized the inherent dangers involved. The impact of a tragic submarine incident and nuclear contamination. After the submarine surfaced, it sank at 17:08, leaving only 27 of the 69 people on board to survive. Due to the large concentration of nuclear fuel aboard, the Comso Incident submarine, which also carried 2 nuclear warheads, the primary consequence of this incident was atomic contamination. This is one of the most significant nuclear accidents in history, with the radioactive material in its sunken location posing a persistent hazard for more than 30 years. This incident has significantly impacted the local waters and the communities that live along them. Limitations of manned aircraft and the significance of nuclear-powered aircraft. Additionally, the limitations of human-crewed aircraft should be taken into account. Despite the emergence of unlimited range capabilities, manned aircraft pilots cannot endure extended durations due to various constraints, such as radiation exposure during missions. Therefore, nuclear-powered aircraft were solely an innovation of conventional fighter planes at that time for the United States and the Soviet Union. In a practical sense, its significance was limited. Breakthrough in nuclear reactor miniaturization with Lockheed Martin's CFR Technology. However, the Lockheed Martin developed CFR mini fusion reactor represents a significant departure. After decades of research and development, Lockheed Martin has achieved the capability to miniaturize nuclear reactors, which, combined with the considerable advances in uncrewed aerial vehicles or UAVs, represents a breakthrough. The previously mentioned disadvantages of nuclear-powered aircraft may be mitigated by CFR technology. Unveiling Lockheed Martin CFR Miniature Fusion Reactor. Considering some observers may not have seen the GI video, let's examine Lockheed Martin's CFR Miniature Fusion Reactor. Lockheed Martin's research and development team declared the project publicly on the Google Solve For X Forum on October 15, 2014. The project was initiated on February 7, 2013 and was made public on that date. The CFR miniature nuclear fusion reactor accomplished a technological breakthrough, resulting in the filing of the pertinent patent applications. Within the next decade, it is anticipated that the first compact truck-mounted reactor will be created. Lockheed Martin's covert CFR research in collaboration with the military. Tom McGuire, the director of the project and a member of the research and development team, has been working covertly on fusion energy for 4 years, implying that Lockheed Martin has been conducting CFR research since 2010. As a cutting-edge American technology company, Lockheed Martin is logically capable of initiating revolutionary changes in the aviation industry. Consequently, it is wholly plausible that they would work with the U.S. military to develop similar equipment. Lockheed Martin's decision to release CFR technology. Why did Lockheed Martin decide to release the CFR technology to the public? Upon examining the pertinent data, it becomes clear that the company initially did not treat the CFR seriously and only allocated funds for research and development. This is understandable given that fusion technology on a large scale has yet to be available for practical application. However, by pursuing miniature fusion, Lockheed Martin intended to reduce the size of the reactor significantly. According to the 2014 Lockheed Martin file, the CFR reactor is 90% smaller than a conventional large nuclear reactor, measuring only 7 by 10 feet, about 2 meters in diameter, and more than 3 meters long. This starkly contrasts with NASA's 10 kWe nuclear fission reactor announced for 2019 and is even smaller. Lockheed Martin's strategic approach to CFR development. Lockheed Martin's decision to make the CFR technology public was motivated by the need to share risk externally. They plan to jointly develop the technology and reduce financial risks by seeking prospective industry or government partners. This strategic action is consistent with the information disclosed by Lockheed Martin, which emphasizes the size reduction achieved by the CFR reactor and its potential for additional conversion. Examining the efficiency and capacity of CFR microfusion reactors. Only 30% of CFR microfusion reactors convert. Each device generates 1 to 10 kilowatts. Given this, its power may be questioned. 1 kilowatt powers a refrigerator for 1 day, whereas 10 kilowatts power 10 units. The CFR reactor burns 11 kilos of deuterium and tritium. The fusion reaction can continually generate 100 megawatts of electricity to power over 80,000 houses. The CFR reactor can run for 1 year, unlike the 10 kilowatt reactor, which can run for 15 years. It can still power large cargo ships and aircraft. Potential applications and speculations. The CFR initiative team provides public photos. The photographs show that the CFR technology will be used on automobiles, aircraft, and aircraft carriers, even though the transmission date is unknown. Lockheed Martin CFR team's first product, the CFR Fusion Reactor 110, powers Figure 1's 4 demonstrations. Plasma from the fusion process powers the reactor. Fusion Reactor 110 generates a lot of heat that can be converted into energy. Heat can cause steam to power turbines and generators. Heat could replace combustion chambers in turbofan and turbojet engines. Figure 1's F-16-like plane is intriguing. Lockheed Martin may have developed an unnamed F-16 using CFR small fusion reactor technology around 2010. This speculation is confidential. And that completes our video for today. We hope you enjoyed learning the incredible history of CFR technology. Which of them are you most excited about? Tell us in the comments below. Thank you for watching. Don't forget to like this video and subscribe to TECHBROS for more content such as this.